Elektro mit c-sport.de
Hi everyone, and thanks for joining today's Electrosport videocast. Today I'm discussing how electric unicycles work and what makes them balancing you without letting you fall over. Some of you might have already driven an electric unicycle. Leaning forward will accelerate and the unicycle and you can slow down by leaning backward. But why does this work? Well, let's have a look into the wheel. First of all, we have an entire little computer in here, and just like any computer, this board hosts a central processing unit, acting as the brain, making decisions and controls the motor, sound and light. The second key component is this gyroscope. What does it do? You can think of it as an electric version of a water level. And we all know it from our smartphones. Rotating the phone will have the display follow the rotation. But that's not all what is required to control the movement. Here, within the motor, there is the so-called Hall sensor. Well, actually 3 altogether. They measure the direction the wheel spins as well as the rotation speed. Here in the top are the FET, electronic transistors for high power voltages. You can think of it as an electric switch which controls the motor. The motor here contains numerous small coils which under electric currents repulse from the fixed neodymium magnets inside the wheel rim. These neodymium magnets are quite strong. I've prepared a little experiment visualizing the principle of electrostatic repulsion. I've prepared a copper coil, leaving enough space to place this small magnet inside it. Afterwards, we put current on the coil. The magnet field is building in the coil that creates a repulsion force propelling the magnet out of the coil. Here again in slow motion, putting the coil under electric current, the magnet is jumping off due to electrostatic repulsion. This force is the secret behind why the motor can spin. Well, and finally, to run the entire show, it requires an energy source providing the energy for motor, processor and peripherals. These are the lithium-ion packs consisting of so-called 18650 type industrial batteries wired in series to allow the high voltage the motor requires to keep the driver stable. But how do these components interact in detail? The CPU continuously receives inputs from the gyroscope on axis orientation and acceleration. If the driver leans forward, the angel of the wheel tilts forward. In response, the CPU instructs the transistors to give more energy to the motor. The transistors are pairs of 3, with each transistor being paired with every third coil in the motor, pulsing the current at the shifted phases through the copper coils, creating electrostatic repulsion from the fixed neodymium magnets. As the magnets inside of the rim can pivot around the coil, the motor will start to spin. The wheel could now run faster and faster, but the Hall sensor realizes the rotation speed, feeds back the rotation speed to the CPU, which in turn slows down the pulse frequency of the transistors, controlling the speed down. Oh sir, if you hear the warning beep arriving the maximum speed, this is all measured by these Hall sensors. You might already know that this motor here is a so-called direct drive, sometimes also referred to as brushless design. Why? Let's have a look at a common motor. This one allows us looking into the motor to see the coils fixed on the axis allowing to spin. As the spinning coils needs to be under current continuously, it requires these little brushes acting as contacts to transfer the energy into through the rotating coil. This constant grinding is not free of wear and tear. Our direct drive motor, however, follows a different design concept. The inner coil is fixed while the outer rim with the neodymium magnets rotates around the coil. This makes the motor almost free of wear and tear, having a very long lifespan. Let's take a look back at the gyroscope sensor. Those of you already having an electric unicycle know already that once you lift the wheel, the tire starts to quickly spin intentionally. But that's not the case. The reason for the strong acceleration is that we almost never lift the wheel in perfect balance. The motor starts spinning because of the very sensitive gyroscope. Here another experiment to illustrate my case. You can spot the white bands I've bound around the tire at fixed intervals. With a bit of care it's possible to lift the unicycle slowly, causing almost no rotations of the wheel. You can even let it spin and control the direction of the spin, playing tricks on the gyroscope. I invite every owner of a unicycle to try it out. An entirely different aspect of the gyroscope sensor is the safety side tilt shutdown. In case the wheel falls, it cannot continue to spin for obvious safety reasons. To demonstrate this tilt shutdown, I switch on the fire wheel and slowly lean it sideways. You can hear it emits a warning message indicating the safety shutdown. Now taking it up again, the motor is still off. So there is no risk the wheel to suddenly catapult away, preventing potential injuries.
Elektro mit C-Sport.de